Okay, so we're doing 1.3. We're talking about exponential functions, one of the most important ones we do in the class. Okay, so let's get started. Here's our warm-up. You watch funny TikTok on your phone before or after school, not during school, you dirty criminal, and determine it's worthy of reposting, so you send it to all 7 of your closest friends. Just so happens that each of your 7 friends also has 7 friends they send it to. How many people have seen it now besides you? So now we would have 7 times 7, 49 people. Each of them sends it to 7 more friends. How many have seen it now? 343 people. So this is just increasing. X is the number of rounds. After 2 rounds, this was 7 squared, 7 to the third. So after the number of rounds, we get 7 to the x. Now, to see how long it would take to get to 57,000 people, you just keep plugging in x. And we got like at 7 to the 5th, we get 16,000-ish. And at 7 to the 6th, we get 117,000. So between 5 and 6 rounds. Same thing here. To the 11th, you'd get about 1.9 billion. And to the 12th, you'd get almost 14 billion. So somewhere between 11 and 12 rounds. We don't have to answer that much. Just illustrating how fast these things can rise. So let's talk about exponential function. F of x equals b to the x. Sometimes it's f of x equals a times b to the x, where a is an initial value. For example, if in the warm-up 3 of you had seen the video at the same time and sent it to 7 friends each, we'd have start with 3 times 7 to the x. There's a common ratio in the outputs. You're multiplying by the same number each time. Okay, so let's get into it. Grab your calculator. I want you to fill this table out. Pause it, fill this table out because we need to talk about what happens. And I'll come back after when you unpause it and have the table set for you. Okay. So basically here, b is greater than 1, and as x increases, y is increasing. As x increases, y is increasing. Not by much, but it's increasing. Okay? Over here, x is greater than 0, so 0 is less than x, but now x is less than 1. This just says x is between 0 and 1. So now, as x increases, y is decreasing. We went from 1 to 1/2 to 1/4 to 1/8. And over here, we went down just a little bit from 1 to 0.99 to 0.9801 and down just a little bit more, losing about 1% each time. So when b is greater than 1, y increases. When b is between 0 and 1, y decreases. By the way, I'm sorry, I messed that up here. This should be b, the base. And so when b is greater than 1, we have exponential growth. When b is less than 1, we have exponential decay. Getting smaller and smaller. Okay, so this one, you can take all this to Desmos. Don't put in this one just yet, but go to Desmos. Matter of fact, let's just do it here real quick. We add a table. And we're doing 2, 4, 6, 8. And we're doing 38, 156, 638, 25, 55. And if you do a little zoom, you can tell that's pretty exponential right there. Sort of linear regression, just to illustrate what we saw yesterday. Linear is going to be bad. If you run your residual plot, you see a definite pattern in your residual plot, meaning linear is not the right way to go. So we're doing exponential equations, functions here in our lesson. So let's do an exponential. This is really important. R squared is 1. The closer R squared is to 1, the better your model is. Okay? These residuals are not off by much. So we did really good here. So here is your function. and we'll go back and talk about that. So there's your function. Based on your equation, regression equation, how many rabbits would you expect to have been present at month 0? Well, I put in 0 for this. Well, anything to the 0 power is 1. So you're just talking 9.83585 to the first power. Yes, we have 9.38, I'm sorry, these should be 8 threes. I have an extra 3 in there, I apologize. We have 9.8 rabbits. Yes, we're estimating, so we have around 10 rabbits to start with. This was before anything started. So now it says after 1 year. Well, the problem with this is in months. So we don't just raise it to the first power, we raise it to the 12th power. About 41,183 rabbits. Now it says, your friend says that it looks like the number of rabbits quadruples every 2 months. Therefore, an appropriate function for us could be 9.5 times 4 to the t power, where t is time. T is the number of months. No, they're not right, because it quadruples every 2 months, so t would need to be in units of 2 months. You could like make this t over 2, but basically t is in terms of single months, not 2 months periods. So it's not, this is showing that it's quadrupling every month, when this is showing it's all but quadrupling every 2 months. So yeah, that's the bad part. Okay. So we have a times b to the x. A is called the initial, or a is the initial population or value. B is called the base. Now, what would b be if the function was increasing by 9%? So I take $100 and I multiply it by something, by 9%. What would I have after a year? Well, 100, let's remember, 9% is 0.09, not 0.9. So 109% of 100 would be $9. So I want this to equal 9, or I'm sorry, 109. Because I want to add that to that. I want to add that plus 100. So the idea is I want to multiply by 100% plus the 9%. And so that's what I'm going to get here. Oops, there's a spoiler. So to increase it, I would do whatever 100 times 1.09 to the t or to the x. This would be my function if I was increasing by 9% every year. Now to decrease by 9%, well, I want to subtract this 9. I'd be at $91. So now I need to do 100 times something equals $91. Well, that would be 91%. Think about it this way. I'm taking this out of 100. So I do 100 minus and get 0.91. So I'd have 91% of 100 after 1 year if I decreased by 9%. So I'm multiplying by 0.91. That's kind of the weird thing here. So the rate of growth or decay is whatever b is minus 1. So here, b is 1.075, so I do 1 minus 1.075, and I get 0.075. So I'm decreasing, positive growth, negative decay, so I'm decreasing, I'm growing here by 7.5%. So here, I do 1 minus 0.87. Students wanting to tell me I'm decreasing by 87%. I'm getting 87% of my original value, so I'm losing 13%. So I'm going down by 13%. Over here, 1 minus 1.003, can't draw my 3 there, would give me 0.3%. Or, yeah. Okay, there you go. There's exponential functions.